Okay, today we are going to have a brief introduction on one of the topic called the quadratic equation. This topic I have taken from the 10th standard maths quadratic equation, and we will discuss about what is the quadratic equation and how to find out the solution. So before we go into detail, let us know about why it is called quadratic. Wherever the word quadratic used, it means the degree of the equation will be 2. Degree is what? Degree is the highest exponent of the variable in the equation. In case of single variable, that is highest exponent, and in case of multivariable, for example 2 variable, so the degree will be highest exponent of the 2 variables or 3 variables, as many included in that. So anyway, we are discussing about the quadratic equation. So let us see the standard form of quadratic equation. Standard form of quadratic equation is ax square plus bx plus c equals to 0. Here the x is the variable, whereas a, b, c, these are treated as constants. a, b, c are taken as constants, and if we talk about the degree of this equation, so we can see clearly the highest exponent of the variable, which is x in this case, is 2. This means the degree of this equation is 2. This is why it is called the quadratic equation. And one more condition for quadratic equation: these a, b, c are actually the coefficients of x square, and the constant term. The values of a, b, c may be anything, but the coefficient of the x square, which is a in this case, this cannot be 0. So a is not equal to 0, because if a becomes 0, so this whole term will reduces to 0. Then we will left with only bx plus c. So this is not going to be quadratic. This will be a linear equation. This is why a is not equal to 0. It means a cannot be taken as 0. Okay, this is the quadratic equation, and a, b, c are the constants, coefficients of x square, x, and the constant term. Now discuss about the solution of the quadratic equation. Solution. Quadratic equation. Solution of any type of equation, not specifically quadratic, any type of equation, whether it is linear, quadratic, cubic, or biquadratic. Whenever we talk about the solution of an equation, this means a specific or the particular value of the variable for which the polynomial or the equation satisfies. For example, if we have the ax square plus bx plus c is equal to 0, it means x will have some particular value for which this equation will hold. So that is called the solution of quadratic equation. If we want to find out the solution of quadratic equation, so there are basically two methods. First method is by factorizing the equation into product of linear factor. But this method has some restrictions and some limitations, because using this method all types of quadratic equation cannot be solved. For example, we will factorize the given quadratic equation into linear factor, then we will equate to 0, then we will find the solution. Let's take an example. Suppose if I have taken x square minus 5x plus 6. So this method is also called the by splitting middle term method. Splitting middle term. So using this method, if we want to factorize this, so clearly we can write down x square and minus 5x can be written as minus 3x minus 2. Actually there is one more condition. Here the coefficient of x square is 1, so when we multiply 1 into 6, this is going to be 6, which is positive. Now we will look for any two integers whose sum is 5 and the product is 6. We know that those integers are 3 and 2, so we have simply split this 5 and this is plus 6 equal to 0. Now group these two terms together, and using in this first group we can common out x, take x, and this is minus 3, and here we will take common minus 2, so this will be minus 3, and again x minus 3 is common to the both factors, and we will left with only this much of. It means we have factorized this given quadratic equation into the product of linear factor. Now if you want to find the solution, then one by one we will equate it equal to 0. So when x minus 3 equal to 0, this will give you x equal to 3, and when x minus 2 is equals to 0, this will give you x equal to 2. So this is how we can find the solution of quadratic equation using the factorization method, but it has some limitation. What type of limitation I am talking about? Using this equation, this method, we cannot find out the solution of all types of quadratic equation. It means there is some conditions on which the nature of the solution or the roots, it is also called the roots, depends on. So now we are going to discuss that what is the condition on which the nature of the roots or the solution of the quadratic equation depends on. And that condition is, suppose this is ax square plus bx plus c equal to 0. Actually using the factorization method we can find out the solution of only those quadratic equation which has real roots or solution. Actually 3 and 2 are real values, so this is limitation of this method. We will be able to find out only those types of quadratic equation which has the real roots or solution. But what about in those cases in which there is no real roots? So there is another method called the quadratic equation, or sorry, quadratic formula. No, this is ax square plus bx plus c. This is quadratic equation. There is one more term called the discriminant. One of the term called discriminant, capital D. So capital D discriminant can be written as b square minus 4ac. This is how we have to calculate the discriminant of the quadratic equation, and this is found by the completing the square method. We can also discuss that, but here we are confined to discuss the nature of the roots only, so we are not going to that. Simply this is discriminant b square minus 4ac. Now the nature of roots of the solution. Nature of roots or solution depends on the discriminant. Let's see how. If this is d, there are three conditions. First condition, suppose this is equation number 1. So equation 1 will have real and distinct. Real means real roots and distinct means different roots. It means roots are not same. So equation will have real and distinct root if condition is when discriminant d, which is written here, is greater than 0, or we can say discriminant is positive. The second condition is equation 1 will have real and equal roots if. So to have the real and equal roots, condition is discriminant is 0. If this whole discriminant reduces to 0, then equation will have real and equal roots. The third one is equation 1 will have no real roots. If so, equation will have no real roots. The condition for this is d is less than 0. This means when the discriminant becomes negative, then equation has no real roots, and then we will not be able to express the given quadratic equation into the product of real linear factor. Real means with a real solution. If we consider the complex roots also, like x plus iy, then that would be possible. For example, if I write x square plus 4, so we cannot express this quadratic equation to the product of the real linear factor. If it would have x square minus 4, so we could express this like x plus 2 and x minus 2, but it is plus 4. So if we factorize into complex root, so we can write down like x plus 2y and x minus 2y. But in the case of no real roots, discriminant is less than 0. Now for example, let's take some examples and discuss how it works on. Let's take one example. Suppose I have taken 2x square plus 5x plus 3 equal to 0. If we find the discriminant here, we know this is a, this is b, and this constant term is c. So discriminant is b square minus 4ac. b square means 25, 5 square minus 4 into a is 2, c is 3. This is 25 and 4 to the 8 is 24. This is 24. 25 minus 24, this is 1. Discriminant is positive. So if the discriminant is positive, so this equation will have real roots, real and distinct. But there is one more case in which equation will have no real roots. For example, x square 2x square minus 7x plus 6 equal to 0. Let's take this example. Again find the discriminant. Here value of b, that is the coefficient of x, is minus 7. So b square, it means minus 7 square minus 4 into a is 2 and c is 6. So this is 7 square, this is 49, and this is 4 to the 8, it is a 48. This is 49 minus 48. So discriminant is going to be 1. So coincidentally, this equation will have the real roots and real and distinct roots, because here discriminant has become positive, which is greater than 0. Let's make one change in this equation and then see what will happen. Simply what I am going to do here, I am simply changing this constant term. If I replace this constant term by, suppose, by 10, now for this equation, let's see what condition is going to be. Now when we find the discriminant of this quadratic equation, now d is b square, b is minus 7 of whole square, and then minus 4 into a is 2 and the c is 10. This is 49 and 4 to the 8, and 8 into 10, this is going to be 80. Now obviously we can see this is going to be negative because the 80 is greater than 49, so this is not positive, this becomes less than 0. So in this case, no real roots. Equation will have no real roots. It means this quadratic equation cannot be expressed as a product of the two linear factors. Thank you. This was the brief introduction on the quadratic equation, and the nature of roots,